start recording. Okay, so like I said, we finished up with 1.6. So if you have any specific questions on 1.6, go ahead and email that to me now. I'm going to look at an epsilon delta limit when I get into the whiteboard for the square root of x, a right-handed limit at 0, and kind of show you how that might look. You guys have been doing it for lines. That's what I expect that you know how to do inside and out. I'm going to give a half a test sometime next week. So it sounds like everybody's planning on being back October 1st. So I'll plan on joining you in the classroom and giving you, you can either consider it a 50-point quiz or a half a test. And anyway, so we'll plan on that during homecoming week. So I'm sure you got nothing else going on there. Welcome back to class for those of you that arrive on Thursday with a half test. So I want to make sure that through section 1.7, which I'm going to cover some of that today too, that you're all good on that stuff. And then I'm going to keep going though, try and get the chapter finished up and stuff like that. But I do want to at least give you a flavor of what a test could have on it, those types of things. So we'll do that. Remember your assignments that you're turning in, they're worth 10 to 15 points each. Those are the same points as test points. So the reality is if you had 5 assignments worth 10 points each, a half test that I'm going to give you next Thursday is worth the same amount of points. So I do want to make sure that you're communicating with each other. WhatsApp's great. I appreciate Isaac reaching out and kind of being the guinea pig, so to speak, on that. When it's odds, I'll give you as much information as you want. When it's evens for you to turn in, I kind of want that to be the WhatsApp to be other people helping out and saying what you did and stuff like that too. So that's the only reason, Isaac, I was not giving you more information. Hopefully you got that figured out. And if your teammates in the class are letting you down, then reach out to me individually after that. And I'll be happy to work through individual questions and stuff too. So anyway, I don't see anything in the chat function on specific questions for 1.6. So were the one-sided limits okay? They weren't really making you do any epsilon delta. I'll assume that's all good unless something pops up. And I will go to the whiteboard now. I do have Khan Academy. I can't get logged in. It doesn't show my username or password, so I didn't realize that I'm using a new machine here that didn't save it on there. Khan Academy has some real nice quick application stuff, so I do want you to be able to work through those on limits where it's just quick hitters, stuff like that, and then kind of work through. So I'll show that too. I'll show it more in detail, but as far as Khan Academy goes, there's like video clips there, there's notes, different things like that. There's people explaining stuff. Ultimately, I care that you do the exercises and then the quizzes and then the unit test at the end. If you want to use the other stuff as a resource, you can. If what I'm doing for you is more than sufficient for you to completely understand stuff, that's okay too. But I think you'll like the Khan along with it. Anyway, but apparently I got to get you signed up on that. So I do have that to share. I'll probably send out the link via email or WhatsApp. So anyway, if we have time today, we'll do that. Let me go to the whiteboard and just kind of finish up one with section 1.6. So what if I had the limit as x goes to 0 from the right of the square root of x? And the question is, if I want to prove using epsilon delta that the limit as x approaches 0 from the right, well, if we plug that in, that's going to be the square root of a tiny positive number, right? So I kind of write that when I plug it in, limit of the root is the root of the limit. If I'm using it's the square root of a positive 0, which is actually 0, right? Which from the graph, that makes sense as well. This makes complete sense that when I have my half a parabola turned on its side, and as I approach 0 from the right, we'll use red from the right, when x approaches 0 from the right, my graph approaches a height of 0 there as well. So anyway, this makes sense, but if I want to prove this using epsilon delta, how would that work? So for the right-handed limit, remember we had, first of all, what's the domain of f? The domain of f is including 0 to infinity, so it is defined on some open interval containing 0 except possibly 0 itself to the right. So really for right-handed limit, we just need to show that including 0 to some open interval to the right of that, and I could go over to 1 or 2 or 10, but I can go all the way to infinity. So I only have to be defined to the right. So that's another thing on the definition or the formal definition. Okay, so the right-handed limit, let f be defined on, instead of I or I minus a, where I is some open interval, I can just say from A to C, some open interval containing A, and then going to the right. So this would be where C is greater than A, right? C is greater than A, not 0. In this case, A is 0, but in general, it's going to be A. Then basically what I have is then the limit as x approaches A from the right of f of x exists and equals L if and only if for all epsilons greater than 0, there exists a delta greater than 0 such that, and then what's different here is instead of having the absolute value of x minus a, I don't need that. I don't need the absolute values because x is going to be some number bigger than a. So I just have x minus a, not the absolute value of x minus a is less than delta, would imply the absolute value of f of x minus L is less than epsilon. So for that vertical window, we're not sure which is bigger, the f of x's as you get close to a, or the limit itself, you could be above or below. So I do need the absolute values over on the epsilon window, but I do not need them on the left for a right-handed limit. So once again, this is a right-handed limit. So I'm defined to the right of a on some open interval, and then I got to do this. So let's do this for the function that we had. We've got the limit as x approaches 0 from the right of the square root of x exists and equals 0. So basically, I've already shown it's defined to the right. And then, so for the proof, we're going to do some scratch work. We're going to let epsilon be greater than 0. And then we need to find the delta greater than 0 such that what happens? Well, in this case, the absolute value of 0 is less than x minus a is 0, is less than delta, would imply the absolute value of f of x, which is the square root of x, minus L, which we're also saying is 0, is going to be less than epsilon. So really what I got to do is I got to find that delta, right? So what I can do is just work with the right side. So I've got absolute value of the square root of x is less than epsilon. The square root of x is the positive square root of x, right? So that's already going to be a positive number, or at the smallest 0. So that just implies that the square root of x is less than epsilon. And then what I could do here is I could square both sides. And since square root of x is greater than 0 and epsilon is greater than 0, if I square both sides, it's positive times a positive. The inequality holds, and I'm going to get x is less than epsilon squared. Well, on the right, or on the left, I can just say, x is less than delta, and over here I've got x is less than epsilon squared. So simply I can set delta equal to epsilon squared. And then you can keep going and work backwards. So on the proof, then, we can go let epsilon be greater than 0, set delta equal to epsilon squared, and then keep going and work backwards. And I'm not going to work through the rest of that. I just wanted to show you one that's not a line, and so we can still come up with epsilon delta window. Once again, this process does try to get the biggest delta window around it that's still around A that still works. And once again, this delta window is to the right only. So if I'm drawing this graph, basically here's A, which is 0, it's to the right. So this is 0 plus delta here is only to the right. So the x's that I'm using here are in here, and then the epsilon window is around 0. So it's actually only above in this case. So this would be 0 plus epsilon, 0 minus epsilon. So minus epsilon to plus epsilon is the vertical window around the limit of a height of 0 in this case. All right. So now let's move on. So no other questions from 1.6. Hopefully, remember, just real quick example. If I have, you know, a function that looks like this, there's my function, and here's A, then, and let's just call this, let's say that has a height of 1 there, that has a height of 3 here, and this has a height of 2 here. Well, the right-handed limit at x equals A is, as x approaches A, is going to equal 3, right? The left-handed limit at x equals A, as you approach A from the left, you approach that open hole of 1, a height of 1, right? And so what I can say is the limit as x approaches A from both sides of f of x does not exist, right? Because the right-handed and left-handed limits both exist but are not equal. Also, just to summarize, hopefully that makes sense. We also know that, just as a note, f of A in this case exists and equals 2, right? So I don't care what A is. If this is, you know, if this is 5 here, f5 would actually equal 2, right? But that's not the limit. The limit as x approaches 5 of f of x still does not exist, because the right-handed limit comes on this hole, the left-handed limit comes on that hole. All right. And then if I also, for our example that we had for the square root of x, so if I say, what's the limit as x approaches 0 of the square root of x? The answer to this is, somebody might say, well, limit of the root is the root of the limit, plug it in, I get the square root of 0, which is 0. But actually, this does not exist. And why is that? That's because the right-handed limit would be the limit as x approaches 0 from the right of the square root of x, which is the square root of a positive 0, which is 0, right? But the left-handed limit would be the limit as x approaches 0 from the left of the square root of x. And if I did this, I got to pay attention to what kind of number is getting put in there. So I'm putting in a tiny, remember, I can get as close as I want to 0 from the left, but I can't actually touch 0. So in other words, this is a tiny negative number, and this does not exist. You cannot take the square root of a negative number. So the left-handed limit doesn't exist. So the limit from both sides definitely does not exist either. So we do have to pay attention to if it's a right-handed limit, a left-handed limit, or if I don't have a particular sign on there, like I do here and here, then it's the limit from both sides. Okay, so just a couple of talking points there to keep in mind. And then now we can move on to section 1.7. Once again, this is the last section before that I'll cover before your half test next week. So by doing it on Thursday when everybody's back, not only is everybody back, but I'm also going to make sure that you don't have any questions or things of that nature. So what we're going to do in section 1.7 is we're going to look at infinite limits. Because so far we have only been approaching specific height values, but the reality is we can approach an asymptote. So if I have, for example, if I have f of x equals 1 over x squared, we know what the graph looks like, right? That's arcs in quadrants 1 and 2. And basically, if I look at the limit as x approaches 0 from both sides of 1 over x squared, that's actually going to explode. So I'm going to look at this. I'm going to use red from the right. So as x approaches 0 from the right, as I get closer and closer to 0 from the right, this gets bigger and bigger and bigger, right? So basically, if I look at the right-handed limit, it's going to be 1 over a positive 0 quantity squared. So if I have a fixed positive number divided by something that's getting smaller and smaller and smaller, it's going to actually explode. And since it's positive divided by positive, it's going to explode to positive infinity, right? Now, if I look at from the left, and I'll use green from here, I think I was using blue or green, whatever. As I approach from the left, what happens, I do the same thing. So the left-handed limit, it also explodes upward. And so basically, if I plug in a negative 0, but remember it's quantity squared here, so a negative tiny number times a negative tiny number is going to be a positive tiny number. So it ends up being 1 over a positive 0 again, and that's going to explode toward positive infinity. So the left and the right-handed limits both exist and are equal. So we're actually going to be able to say that this has an infinite limit. Okay, infinite limit here. So the as I approach 0 from both sides, my height is approaching positive infinity. So the question might be, how can you prove an infinite limit? Remember, infinity means increasing without bound. So here's what we do. Instead of taking a tiny epsilon window, what I can do is I can look at some number, we're going to call it capital N. And if you pick any, what I like to call, for the sake of just don't show anybody my recordings, N is a big ass number. Okay, so think of N as some big ass number. It could be, if you think a million is big, this could be a million to the millionth power. I mean, it could be a Google, right? This could be way up there. And if you give me any N value, basically what I can do then is get a window around A, which in this case is 0, such that all of these mappings of X's would end up mapping above that height of Y equals N. So if they would all shoot above that, no matter how big of an N you get, then that's the theory part of how to prove an infinite limit. So I will give you that, but I wanted to show you a picture first. So basically, if you say, hey, you know, I'm going to pick N is 100. Well, if I'm within 1/10, 1 over 1/10 squared is 100. If I'm within 1/10, all those mappings would go above there. And minus a tenth, if I squared is 100. When you have 1 over minus 1/10 quantity squared is also 100. So if I had N equals 100, then basically my delta would actually equal 1/10, would actually allow all the X's in there to shoot above that height. Because the farthest to the right I could be is over at 1/10. The farthest left my X's could be is left 1/10. That would be the open interval around 0. So if I plug in 1/100th, I'm going to actually get 10,000, which actually maps well above that given height. Okay. So I'll give you an example. Hopefully that makes sense. So let's just look at the definition of an infinite limit with epsilon delta. So once again, this is the formal definition. And I know you're going to like the concept of all of these things much better than epsilon delta, but that's the theory that you get from me, okay? That's the college level part of it. So we're going to let, once again, we're going to let the domain of our function equal some open interval containing A except possibly A itself. So we can just shorthand add by saying I is some open interval around A, or I minus the set containing A. Then we're going to define an infinite limit. The limit as X approaches A of f of X exists and equals positive infinity if and only if, and then we got to try and make sense of that picture. So we're going to say, instead of for any epsilon window, we're going to say for any big ass N greater than 0, there's going to exist a delta greater than 0 around X equals A, such that what happens? 0 is less than the absolute value of x minus a is less than delta. That's the exact same as before. But what's that going to imply? That's going to imply that f of x is going to be all these x's that we plug in, their heights are going to be bigger than that big ass n. They're going to be above it. And if that's the case, then the limit is going to actually equal positive infinity. And once again, this is from both sides. So one question you might have, well, Tim, why don't I need an absolute value around that f of x? Well, if n is a big ass number, it's going to be a big ass positive number because we said n is any positive number. So if I'm going to be above a positive number, f of x is also going to be a positive number. And so the output has to be above that horizontal line that I was drawing before. So I'll give you one example of this. Let's do the one that I just said. If I f of x is 1 over x squared, and we're going to use the instead of epsilon delta, this is going to be n delta. So we're going to prove it using n delta instead of epsilon delta. Okay, so first of all, proof. We're going to do scratch work. Let n be some big ass number. Let n be greater than 0. And then what we need to do is we need to find a delta greater than 0 such that what happens? 0, excuse me. Yeah, no, that was right. I wish I had an eraser. I probably do, but I don't know how to erase anything but the whole screen. 0 is less than the absolute value of x minus a. Well, a in this case is 0, right? For the 1 over x squared. We're trying to prove the limit as x approaches 0 from both sides of 1 over x squared equals positive infinity. So if this is less than delta, then that's going to imply that f of x, which is 1 over x squared, is going to be bigger than that big ass n, right? And so what we're going to do, similar to before, is we're going to keep working with the right. So we're going to keep working with this. And what I'm going to do is I'm going to try and get, I need to try and find my delta. So if I multiply both sides by x squared, I get 1 is greater than n times x squared. Now the question would be, does that inequality change? The answer is no, because x squared is going to be a positive number, right? Obviously, x can't be 0. We're trying to find the limit as x approaches 0 from both sides. So we're never touching 0 of 1 over x squared, trying to prove that that limit is positive infinity. So it doesn't equal 0. So I'm multiplying by a positive number, so the inequality holds. So this is true since x squared is greater than 0. And then I'm going to keep going here, use different colors. And then what's that imply? Well, what I can do now is divide both sides by n. And if I do that, it's going to imply that 1 over n is on the left, x squared is on the right. And the question is, what happens to the inequality? The inequality holds here. And why does it hold here? It holds here since n is greater than 0, right? N is some big ass positive number. We said that before. So we have that. Now what I can do, what I really have on the right side is I've got the absolute value of x is less than delta. So I need to find that delta. Well, here we need to remember some algebra. And algebra says, so if I have this right here and I just want x, I can take the square root of both sides. So if I take the square root of both sides, I've got the square root of x squared, and if I'm reading it right to left here, would be less than the square root of 1 over n, right? So I'm just reading that inequality backwards. I just decided my x's first. And of course, the absolute value, or the square root of x squared is the absolute value of x. And you can verify that by letting, if x was 4 squared is 16, and the positive square root of 16 is 4, which is the same as the absolute value of 4. But if x is negative 4 quantity squared is positive 16, and the positive square root of positive 16 is positive 4, which actually would be the absolute value of -4. So anyway, so the absolute value of x is less than this. Of course, this is equivalent on the right, the square root of 1 over the square root of n, which is 1 over the square root of n, right? So anyway, the absolute value of x has got to be less than 1 over the square root of n. So what do we know here then? Basically, I found my delta, set delta equal to 1 over the square root of n, and that would make everything shoot above it. And then we can finish our proof formally by saying let n be some big ass number greater than 0 and set delta equal to 1 over the square root of n. Then finish it that way. So I'm gonna let you do that. I'm not gonna take time on that, finishing that out. That's an epsilon delta one. Once again, what have I said that you're gonna have to do for me on the half test and on your test is epsilon delta for a line and showing that specific limit. So let's move on to some other stuff with concepts here. First of all, let's look at another example. Once again, section 1.7. If I've got f of x, and I know it gets boring using f all the time, we could call it g of x or h of x. But anyway, if I've got 1 over x plus 5, what's the domain of f? All reals except where you divide by 0, right? So I'd have to exclude a -5, right? So, and then what happens is this actually ends up being a left shift of 1 over x. 1 over x looks like this, right? But I'm not dividing by 0 when x equals 0. I'm dividing by 0 when x equals -5. So I have a vertical asymptote here when x equals -5, right? So, and then what happens is it's a a left shift. This ends up being a left shift. So the graphing theory that we did early. So there's my picture. And it approaches the x-axis as you get huge to the right or huge to the left. Anyway, it's arcs. Instead of in quadrants 1 and 3, it's shifted to the left, so it's arcs in the upper right of the x equals -5 vertical asymptote and to the left of it and below. All right, so anyway, well, what do we notice here? If we look at the, dang it, let me redraw that. Didn't mean to erase it, but that's okay. So if I have this, by the way, if I plug in 0, I get 1/5, right? So I have a scale. This is x equals -5 there, and then anyway, so we have this. But if I look at the right-handed limit as x approaches -5, looking at the right-handed limit as my x's approach -5 from the right, what does my graph do? So the right-handed limit, so the limit as x approaches -5 from the right. So once again, this is a right-handed limit. Don't worry that it says -5 here. That's what we're approaching, but we're approaching it from the right side, right? Of 1 over x plus 5, this is f of x. What's this going to equal? Let's see, who's paying attention? About Jordan. What's my right-handed here? You may not be able to type it in. You might have to talk it in. You guys still there? There you go.
Positive infinity.
Positive infinity. Awesome. I don't know why. Is there an echo because my side's coming on there too? I need to mute myself when I ask you guys questions. So we're going to try this one more time. So be ready. What's the left-handed limit? I'm going to use blue because blue shows up better. So the left-handed limit, Jordan did the hard one. The limit as x approaches -5 from the left. Once again, we're approaching -5 from the left, getting closer and closer here. the function is 1 over x plus 5. Let's see, Luke. Wait, time.
Negative infinity.
Oh, okay. Are you muted now? I just said some really awesome stuff, and you guys didn't hear any of it because I was still muted. But anyway, the problem was me the whole time. So my wife's here, kind of helping cover the phones because my assistant is gone this week. So I'm gonna have to let her know that, hey, all those times that you said I was the problem, you're probably right. All right, so you guys remember that. Anyway, hopefully she heard that. But this is negative infinity, right? So then with that being said, what is the limit then as I approach negative 5 from both sides? So I'm not putting it one specific side, that means both of 1 over x plus 5. And we'll go
Does not exist.
awesome. I almost started saying awesome again, but it doesn't, because the left-handed limit and the right-handed limit, they do both exist, but they're not equal. Same rules apply. The only way a limit from both sides exists at negative 5 here is if the right and left-handed limits both exist and are equal. So once again, we do not care what happens at negative 5. In fact, in this case, what is f of negative 5, Hannah?
So isn't it like not a thing?
Not a thing, or not, or how would we put it? Does not exist, right? All right, so it does not exist, right? So basically it's not part of the domain, right? Now I could define it piecewise and define a height there, but in general for this function, the domain is all reals excluding that, excluding negative 5. The range would be all reals excluding a height of 0. Okay, by the way, just to give you a little hint on something that's going forward, we could look at, instead of infinite limits, we could look at limits at infinity. And I think we may actually do that. Well, I don't know when we do, maybe Calc 2. But anyway, if I let x approach infinity, the height I approach would be 0, right? And if I let x approach negative infinity, the height I approach would be 0. Out to the right, it's approaching 0 from above, and out to the left, it's approaching 0 from below. But the limit as x approaches infinity, we could actually say that the limit as x approaches infinity, you may see this, of my function 1 over x plus 5 actually exists and equals 0, because that's the height it's approaching out there. So you may see that. We're not really doing that in this section. We're looking at asymptotes and when it explodes up or down. Okay, so if you go to, hey, what do we know? Oh, that's, if you go to khanacademy.org, bring that up. I assume that you can still hear me. Wait. I'm out. I got to get back to, I got to share my screen. I know you're almost done. So like sometimes if I forget that if the bell rings, you got to let me know. But I'm going to share a tab. Okay. What I'm going to do is I'm going to send you a WhatsApp. If you go to khanacademy.org/login, if you do not have, hopefully you can see Khan Academy on your screen. If not, somebody jump in and say no. But anyway, you can hit the sign up button if you've never done it. So I have a specific course and I have assignments ready on limit theory. So try and get logged into this. 1.7 is not going to be formally due tomorrow, but I do want you to read 1.7 and work on exercises on that as well. Should be fairly similar to what you've done. We'll go through a few other things too. But then if you could go to Khan Academy, and it's KAHN, But anyway, and sign up, and then I'll send you a list of what my username and password is. Or not username, my course number. Looks like it's 201. If you have any other questions, send them out on WhatsApp or email me or text me individually. I will go from there. Thanks a lot, guys. Have a good day.